Okay, zero fossil fuel. I confess I've been playing a little bit without you and warming up the cell a little bit. I have a $6 infrared temperature sensor device, and the cell is at 91.8 degrees Fahrenheit. So it's really cooking hot right now. I've been running it at about 30 amps at 14.5 volts. The terminals have remained nice and cool. The negative electrode, however, yesterday when I was messing with it, got quite warm, and I discovered that there was some tarnish that had built up on the copper terminals. So after I scraped that down and tightened everything back up, there was much less resistance at this contact, and then there was no more heat from the current. You can see the HH-ometer. It's ready to go. So I'm going to turn the power supply on, and it is drawing 30 amps at 14.5 volts. So here we go. 1, 2, 3, go. And stop. 14.5 seconds. Crunch that number for you in just a second. And the magic numbers are 2,142 milliliters per minute of production, so a little over 2 liters per minute. At 435 watts in is 4.92 milliliters per minute per watt. Almost 5 mmW, which is about the same efficiency that I remember with the previous cell. So I'm going to let this run for a little while. I'm going to let the temperature increase. It's at 96 degrees Fahrenheit now. We'll try to get this thing up to about 140 degrees Fahrenheit and see if the efficiency changes at all. I presume that it will, but I'm not quite sure. And my terminals just slightly warm to the touch, but so is the 4-gauge wire. So it's actually heat that's being generated by the wire. Interesting.